In the last video, we looked at the alkene cis-trans exception, where two hydrogens can become non-equivalent because they sit in different rigid environments. In this video, we move on to the next big exception, where a CH₂ group is affected by a stereocenter. Here is the trap. These two hydrogens are on the same carbon, so many students count them as one proton environment straight away. But in this molecule, that would be wrong. Same CH₂, equal different signals. For this example, normally hydrogens in the same chemical environment give the same proton NMR signal. For example, in butane, symmetry makes the 2 end CH3 groups equivalent and the two middle CH2 groups equivalent. So butane gives two signals. This carbon marked with an asterisk is the key. It is attached to the hydrogen, fluorine, a methyl group, and an ethyl group. That means it has 4 different groups attached. So it is a stereocenter. Once a stereocenter is present, the two hydrogens on the neighboring CH₂, HA and HB, are no longer in the same environment. Even though they are attached to the same carbon, proton NMR can treat them as different. This is the stereocenter exception. When you have a CH₂ beside a stereocenter, we get two different hydrogen. Now, let's count carefully. The left CH3 is one environment. The proton on the carbon bearing fluorine is a second. The two CH2 hydrogens are different, so they become the third and fourth environments. The right CH3 is the fifth. So this molecule gives 5 signals. Now, compare that with 1 chloropropane. There is no stereocenter here. So for normal proton NMR counting, the two hydrogens on each CH2 are treated as equivalent. That gives 3 signals in total. No stereocenter next to the CH2. The CH2's hydrogen usually remain the same. Try this one yourself. We still have a stereocenter and a carbon attached to fluorine. So the two hydrogens on CH2Cl are different from each other. That gives 1 CH3 environment, 1 CH environment, and 2 different CH2 hydrogens. So the answer is 4 signals. In exam questions, use this shortcut. First, count using symmetry. Then ask, is there a stereocenter nearby? If yes, a CH2 next to it may need to be split into 2 different proton environments. So the big takeaway is this. 2 hydrogens on the same carbon are often equivalent, but not automatically. Do watch out for stereocenters. If a stereocenter makes their environments different, they can give different proton NMR signals.